I'm Anil Kumar sharing with you a test problem on transformation of logarithmic functions. The question here is, sketch the graph of f of x equals to minus 2 divided by log to the base 2 of x plus 2. So I'd like you to pause the video, take up a graph paper and do a neat sketch of this particular function. I'll give you a few steps here in which it could be done. So these are the steps to follow. So let us say this is our coordinate plane, right? So on this, we have to sketch log of 2. So we can write this function as, so what we will do is, we will do it in two forms. We will first sketch log to the base 2 of x plus 2 and then find its reciprocal, right? So then find its reciprocal. That means we'll sketch log to the base 2 of x plus 2, find its reciprocal, and then times it by 2, right? Multiply by 2, minus 2. That is to say, we'll reflect it horizontally and then vertically stretch by a factor of 2. Those are the steps to follow. So starting from the base function, which is log to the base 2, what we can do is, we can sketch a graph which is kind of like this. So I'm doing a very rough sketch for you. So here it is. So let us say this is our base function, which is log to the base 2 of x. Let us say this is log to the base 2 of x, okay? So here this is the point which is 1, and at 2, the value will be 1, correct? At 4, let's say this is 4, this point will be 2 for us. Let's say 2, right? So we have a couple of points to work with. This is for log to the base 2. And if I take a value which is half, right? So x to the power of half, I'll get minus 1 as my point. So we are working with these 3 points for the log to the base. So for log 2x, we are considering the points which are at x equals to half, y value is minus 1, and then for x equals to 1, y value is 0. For x equals to 2, y is 1. For x equals to 4, y is 2. All right? Plus, we have a vertical asymptote. So we'll write vertical asymptote as x equals to 0. So these are good points to work with. And as you can see, the domain of the function log to the base 2x is x is greater than 0, right? So that is the vertical asymptote for us. Is that okay? So first step is, we'll perform from here, we'll shift it horizontally 2 units to left, right? 2 units left means this is 1 and then this is minus 2, right? Minus 2. So when you do 2 units to left, we get a vertical asymptote at minus 2, right? And all these points will move 2 units left. So we have x-intercept here, and this point 2, when you bring it 2 units left, it will be at the y-intercept, and this point 2 units left will be somewhere here, correct? And this point 2 units left will be here. So we have a function which is this function is log to the base 2 of x plus 2. Got it? Now when we do 1 over this, that means the reciprocal of this function, then what happens? Whenever you do reciprocal, at that time the x-intercepts will become asymptotes, right? So that is the key thing. The x-intercept now becomes the vertical asymptote. So now we are doing the reciprocal, this part of this function. So the reciprocal will be 1 over 0 is undefined. So I'm doing this function. So that becomes the asymptote. However, reciprocal of 1 is 1. So this point is invariant. It remains there itself. And the reciprocal of this, which is 2, becomes 1 over 2, right? Half. So this value of 2 will become half, so it will come somewhere here. And as you approach infinity, you are going to approach 0. So this part here will be kind of like this. Do you understand? Now if we look into this part, if this value is, let us say, half, it becomes 2, reciprocal. So the graph on this side actually will be approaching infinitely large value as you approach minus 1, right? Now if you look at this aspect from here, then as you are approaching infinity, we start from here. In that case, the value of the function is 0. However, it is not defined, so we will have a hole here at 0. That's very important to understand. Reciprocal of negative is negative. Reciprocal of minus 1 will be minus 1. As it approaches 0, it approaches a vertical asymptote. So here we will have a function which is like this. So the graph which I have drawn now represents this in blue reciprocal function of the log. So let me write this as 1 over log to the base 2 of x plus 2. I'm purposely giving you all simple steps so that if the question is this, you know how to draw it, correct? Now we will do last and final part of this graph, and that is multiply each point with minus 2. Now if I multiply this point, this is on the x-axis, y value 0, it remains the same. But minus 1 times minus 2 gives me plus 2. So this point will be transferred here, and these points minus infinity will become plus infinity. So we have a function which will be kind of going like this. A vertical asymptote will remain at vertical asymptote, right? So the function in black is your final value. Now here 1 times minus 2 will be minus 2. So this point will really become minus 2. So instead of 1, this will be at minus 2, correct? The point here, which is 2, if I do times minus 2, it becomes minus 4, right? So that is kind of right there. So that is another point. Now here, this is at 2. 2 times minus 2 will be minus 4. So it comes down to minus 4, which is kind of here. No, we are on the blue line, sorry for that. So here we have a point. We have already taken this on the blue line. Now we are actually working on this blue line. This is half. Half times minus 2 will be minus 1. So this point will come at minus 1. A negatively large value, the positive approaching 0 when multiplied by minus 2 will become negative but still approach 0. So we can take those points as shown, right? So these gives us few more points to plot a graph which could be like this, drawing an arrow here. Joining these points will give a function which is like this, correct? So this function is f of x, which is equals to minus 2 over log to the base 2 of x plus 2 as asked for in the question. You see that? And I hope you understand and appreciate how we did it. So I've shown you all the steps in which it can be done. Now, can you write down domain and range of this function, right? So from the graph, the domain and range is very clear. Range has no restrictions, right? So the domain has restriction. So what is the domain? Domain here is that x is between minus 2 to minus 1, right? So that is a minus 1, not including both of them. And then it is from minus 1 to infinity. So that becomes the domain for the function, and the range for the function is y belongs to real numbers, since all the numbers are included except 0. At 0 we have a hole. Do you see that? and y is not equal to 0. So that becomes the range for this particular function, right? So this is a very important function from test point of view. Go through this video, sketch all the steps, and see if you can do it. Thank you and all the best.